Okay, hi everyone. This is going to be the Chapter 5 video for the problems. This is a good one to have as a video lecture. The reason for it is sometimes these tables confuse people, right? They really want to kind of like slow it down, pause it. So at least for the first few examples, I'm going to kind of go and use those tables. But then for the sake of efficiency, right, I'm just going to plug in those factors. So we have some examples we're going to do here. We're not going to do, all of them. Like I said, enough to kind of get you started, know what you're doing. A lot of them are just repeat, do the same thing 4 times in a row. So we'll do it once or twice, and then you just repeat it for the missing ones or look at it. So what are we looking at here in the first one? Right, they want us to determine the future value of a single amount. Right, so this is the future value of $1, right, of a single amount. So what that means is, hey, we're going to be probably using these tables over here, right? So we'll do, 1 and 2 here, right? So $15,000, 6% interest rate, number of period. It looks like we'll do 15,000 times, right, the factor, right? So we got to get our I and our N, right? So that's a 6 and a 12, right? That will give us our future value, right? So if we do this, right, so it's I, 6, and 12. Okay. Oh, geez, that's messy, right? No, we can do it. Don't worry. So future value of $1 versus present value. Oh, we're going to be using this one, future value, right? That's one way you could screw it up on the exam, right? We said the I in this case was 6%, and we said the N was 12%, or 12 periods there, right? So 12 periods at 6%. We got our coordinates. We're playing Battleship. So in the normal situation, right, you're doing the perimeters and then you're working your way to the middle, right? So if we just kind of drag that across here, right, it looks like it's going to be 2.01222. Right, so times 2.0122, and I think it's a 0. Let me check that again. 2.01220. Okay, we run the math on that. We're looking at 30,183. In other words, if you put 15 grand in the bank and had a 6% interest rate after 12 periods, right? Put it in here. It will be worth in the future 30,000. Let's do another, quick example on this, right? So it'll be 20,000 times the factor, right? We got to get the I, the N, right? So it's 8 and 10. Right, so if we go over here, right, it's going to be 8% for 10 periods. Right, we're looking at 2.15, right? You can see it's messy. This is like literally half the battle with this is just not having your eyes go and like be like distracted by all the numbers. I'll try to keep it reasonable on the exam in the sense like the tables are the tables, but be careful when you read them, right? So 2.15, so let's plug that guy in, right? 2.15, 892, run the math on it, right? We're looking at 43,178. Okay, nothing too bad there. Down here, right, they're giving us like the Seinfeld characters and they're saying, hey, who's going to have, at the end of the day, after this time period, the most money in this setup? Now, one of the things I want to call your attention to, and this is another way you can get tricked up, is if you fail to convert the N and the I in light of any type of compounding interest that is not annual, right? So if it's quarterly or semi-annual, you have to convert the I and the N. If it's annual, you're good to go, right? You can use these numbers as given on it. So let's compare over here Jerry with Kramer, right? Just to show the difference on it. So we're trying to figure out what this 13 grand is going to be worth in the future, right? So it'll be 13,000 times, right? We got to get that factor, and we need the I in the end. But here's the deal, right? It's quarterly, so we know we got to convert it, right? So what that means is, right, what we'll do in this case is, so the I is 12%, right? So we'll do 12%, and we'll divide that by quarterly. Oh, that's 4 times a year. Semi-annually, oh, that's 2 times a year. Monthly, oh, that's 12. Right here, we divide by 4. So our I, our converted I, is 3, right? So sometimes people will screw this up. They just put 12 in. No, you needed 3 as your I. You need to convert it. The N, right, if we look here, 6 years, right, but that needs to be converted too. Here we're going to multiply it times the 4 quarterly, right? So that'll give us 24, right, the converted N on it. So again, you would go into the table, and look and find those numbers on it. Sometimes it's not like super easy in the sense that like 24, might not be necessarily in there. If it's on the exam or if it's in the homework, it will be on in these tables, right? Because you can see it like it's capped at 20, or they start sort of skipping a lot there. In those situations, you could hypothetically use Excel in the real world. That's probably really what they would do all the time. But there's an idea with it. And again, we have to convert because, like I said, we're looking at, and when they design these tables, right, this is on like a per period basis. So if you think about it, right, so like for Jerry, yeah, he's getting quarterly 4 times a year over 6 years. Well, then there's 24 total periods. The period is based on the compounding, not, the stated amount. So like over a 6-year period, stated, there are actually 24 periods times where we have this compounding happen. Similar idea there with the interest. If we were to do it with Kramer, right, you would just do the 19,000 times, right, the factor here for the I in the N. You could just use what's given, right? So it would be 10 and 6 because it's annual, right? It's already built into how they design those tables. It's good to go, right? It's only whenever it's something other than annual do you got to convert it. All right, so that was exercise 5.1. We looked at present value there. Now, on the flip side, right, we're going to look at, sorry. Right, so I'm sorry here, I misspoke. We did future value. Now we're doing present value of a single amount. So we're just going in the reverse direction here. We're taking an amount in the future and shrinking it down into today's dollars. Right, so nothing too hard here. right? I mean, we can do one of these or two of them just like we did last time to get you going on it. So if we look at one here, right, it's going to be $20,000, the future amount, times, right, we got to get the I, we got to get the N, 7%, 10 periods, 7%, 10 periods. That will give us our present value. So if we go here, right, this time we have to use the present value tables, right? You could screw that up. You could pick the wrong table. So we have N equals 10, I equals 7, right? We're looking at 0.50835, right? So 0.50835. You run the math on that, 20 times the 0.50, we're looking at 10,617 for it. Okay, so all of these right here and all of these are following the same convention, right? You just take the amount times the factor using the table, right? So you just would repeat what we just did there. Okay, so 510, we're looking at some matching. Come back to that if there's time. Nothing, too hard there. Let's go to 512. All right, a company plans to make 4 annual deposits of $200,000 to help create a special building fund. It looks like they're going to invest the money in that fund in a 12% rate, and they want to know what's it going to be worth after 4 years, right? So really what's going on here, we're going to make 4 deposits, 200 grand, 200 grand, 200 grand, 200 grand. What is it worth, that whole shooting match, at the end of that time, right? So this is really, we're looking at, in this case, in exercise 512, an annuity. And specifically, we're looking at the future value of an annuity, right? That's AKA an ordinary annuity, to be distinguished from the future value of an annuity due, right? That's an annuity due, right? So it's like at the beginning of the period, due now, or ordinary if at the end of the period, okay? So they're going to kind of play a game here with it. They want us to analyze each of these situations independently, right? So we'll do number 1 and number 2, and then we'll kind of move on from this. So number 1 says the 200,000 annual deposits are made at the end of each year, and interest is compounded annually. Okay, nothing too hard here. We know if it's annual, we don't have to convert. We can use the I and N as given. How do we do this for number 1? Right, so it's going to be, right, the future value of an annuity. It's at the end of the period, so we're going to be using the ordinary annuity table, equals essentially the payment under the annuity, the amount, 200,000 times, in this case, the factor, right? We're going to have to use the factor from the table, right? So here, right, we'll have an I and an N, right? So our I is 12% and our N is 4 periods. So how do we do that, right? We got to get that number over here. Oh, okay, we're going to go to future value of an annuity. All right, future value of an ordinary annuity, right? We said it is 12%, the interest rate 4 periods, 1, 2, 3, 4. We're looking at 4.7793, 4.7793, 200,000, times that amount, right? The future value of this annuity is going to be worth $955,900, right? The 200 times the 4.7793 number. Okay, nothing too bad there. Number 2 here. Let's check that out. The annual deposit's the same facts except the payments are made at the beginning of each period. So we're going to be in the other annuity table here, right? The annuity due table because it's made at the beginning. So again, we'll have that same formula, right? So we can use these kind of same overarching variables, 200,000. We'll have the same I in the N, except this time we don't go to the yellow table, we go to the green table. Right, so it's future value of an annuity due. It's N is 4, I is 12, and then we'll go 1, 2, 3, 4. We're looking at 5.3528. Right, so 5.3528. Try to write that as clear as possible. Sometimes these, mouse or mice, I guess, don't work as much as you'd love to. So if you take the 200 times the factor there, we're looking at 1,070,600 for what it's worth, right at the end of the item there. Now, if you notice, right, like one thing that's interesting here, the future value of the annuity due, right, that's bigger than this guy up here, right? And the reason for it makes sense, right? If it's an annuity due, it got a head start, right? I mean, like the first deposit was put and got a head start of a whole year compared to it. So that's the idea with the annuity due. You can have all the same facts and conditions, but if you change the timing, then each payment is going to be, have more time to grow and accrue. All right, let's look at exercise 5.18. This is a good one because it kind of does what accounting loves to do and plays the shell game, right? It's saying, hey, we'll teach this traditionally like A, B, and C, and then we'll test it C, B, and A, right? You got to know this frontwards, backwards, sideways, inside and out. So they're giving us some information here, right? They're saying, here's some annuities. Assume it's compounded annually. So we can put a little smiley face there because we don't have to convert, right? It's easier when it's annual. And the payments are all received at the end of the period. So we know we're dealing with a future value of an annuity table. So we're going to be in this yellow guy right here. Okay, so they give us some setups here, right? So for number 1, they want to know, the present value of the annuity, and it'll be the future value, present value. I'm really referring to this yellow tab, right? They want us to know, whatever the specific amount is. So in this way, right? So let's look at this then, right? Let's take this one step at a time. Let's do number 1 here. They're asking for the classic, the simplest, the present value, right? So they want the present value of the annuity, right? And we know how you would find that, right? It's going to be the payment amount, right? How much time right? Every time they have that little X on there, $3,000 times the factor. Right, and in this case, well, remember we said it's compounded annually, so we can get our I and our N of 8 and 5. If you were to go over to that table, right, the N is 5, I is 8, over here, right, we're using the present value. You would see the factor in that case is 3.99271. Right, you run the numbers on that, you're looking at 11,978. There you go, right? Not too bad, right? We've done some of that. Let's move on to the next one. Right, so the first thing is they hid the ball right here. Now they're hiding the ball there, they're hiding the ball there, there, and there. So we'll do, you know, one of each of these variations just to show you. Okay, so 2 is, if we think about it, right, they're telling us, because we have our little formula up here that's a little bit universal, they're giving us the 242, 980 equals, in this case, 75,000 times the factor, right? We don't know the factor in full in the sense that, yeah, we know in this case the N is 4, but that's our mystery variable, right? How do you do this, right? So you will take, right, so that's kind of like line item 1, you'll take the 242, it's just simple algebra, you move things over, 980, right, that number, divide it by the 75,000, right, so you're just moving this guy over there, you'll divide it, and you will get from this, right, 3.23973. So 3.23973. Geez, these are long items here. What do you do with this, right? I mean, we're looking for this guy right here. How does this even get us there? Well, this is, and essentially what it's looking at is the factor, right? That's the factor. So we're going to use the 4 on this table, right? So it would be the present value of an annuity, right? The number of periods is 4. And then we're going to move and kind of shoot across here until we find that 3.23, right? Oh, there it is, right? Then we can get the 9%. So normally you work like outside, and then you get the bottom number. When they start shuffling the variables, right, it's like you go right and then up, right? So it's like not like super hard, but it's not super intuitive. So here then, right, I is going to equal 9. Right, so that's the idea there. So for the first one, 11,000. For the second one, 9. Let's look at 3, right? What happens if they hide the ball over here on it, right? So I'll draw 3 over here. So we got 161, 214, right? Do that same thing, move it over, right? How we did there, we'll do it here, divide it by 20,000, right? That's going to give us, in this case, a factor of 8.0607, right? We'll then go to the table over there, right? So if we go to this guy right here, so let's think about this, it's 9%, right? They told us that. So we'll start here. Then we'll go down until we find that 8.06 number. Oh, there we go. And then we'll shoot to the left, right? And we'll see that that's 15, right? So in this case, right, when they're hiding the ball the other place, it's like you start up here, you go down, and you go to the left, right? It's like reverse Battleship. The coordinates are mixed up. It's just being able to play the game there, right? So we saw in that case that it's going to equal 15. Finally here, right, 4 is just a repeat of 2. Let's look at 5. So 5 in this case, right, we're going to take the 500,000. We're going to, in this case, I'm sorry, not 500,000. It should be 250,000. We're going to divide that by, when we look at the I and the N, right, when we go to the tables for that, right, if we were to kind of do the Battleship on it, you'd be looking at a factor there of 3.16. So it'll be the 3.16. And to be like super specific for you, 987. Again, in these examples, you can just fill it in like this. I'm just kind of shorthanding it. I mean, if you want to write it all out and then do the algebra with it, I'm just kind of collapsing the steps here to save you some time. That's going to be 78,868, right? So that's just saying, hey, each one of the payments is for 78,868. Let's look. Do we want to do this guy? Nah, I think I'm good on this. You can look at that. I mean, these are just sort of various iterations. Again, things to be careful of is whenever it says like quarterly, semi-annually. Here you're comparing two different things, right? So you're comparing two options, right? So option 1 versus option 2. Right? Do you want to pay 35 grand today or 4,000 at the end of each quarter for the next 4 years? What they're trying to do here is like, do you want 35 grand today? You got to take that annuity, right? The things they're giving you there and shrink that down into today's dollars, right? Because you got to make an apples to apples, more like a cherry or something, right? Comparison on it. So when you run the math on that, this would end up being option 2, something like 39,816.02, right? And it's quarterly, right? So that means you got to convert the N and the I there on it. So you can, I'll just pull the solution over here for a second if you want to pause and look how that works. But I'm not gonna, like I said, I don't want to belabor this video, but if you want to pause and see that one, that's great. Finally, we have the matching. So if we were to look, at the matching on this, so interest, right, that's going to be E, right? It's basically what you get on top of what you put into it. Money isn't free, right? You're going to want to make money on your money. Monetary asset, M, right? Claim to receive a fixed amount of money. Compound interest, J, right? Interest calculated on invested amount plus accumulated interest, right? It compounds, builds upon itself. Simple interest, in distinction, is I, computed by multiplying the invested amount by the interest rate. We have here annuity. That's going to be K, right? A series of equal size cash flows. Each one's the same amount. We have present value of a single amount. That'll be L, right? HIJKL, amount of money required today. That's equivalent to a given amount in the future, right? So we have an amount in the future that we're trying to shrink down to today. Annuity due for 7. That's going to be C. First cash flow begins on the first day. Due now, in the beginning. Future value of a single amount for 8. That guy is going to be D. Right, the amount of money that a dollar will grow to. Right, so we're taking an amount today and seeing what it's worth in the future. Right. Ordinary annuity, 9. That one's going to be A. So first cash flow begins 1 period after the agreement begins. So it means basically at the end, right, versus the beginning for ordinary annuity. Effective rate or yield for 10, that one's going to be B, right, the rate at which money will actually grow, right? So we kind of distinguish that stated rate from the effective rate, what you actually earn on it. When you have compound interest, many times the effective rate can be greater than the stated rate. 11, non-monetary asset. If we look at that, that one's going to be H. No fixed dollar amount attached. 12, or I'm sorry, what number were we on there? 11, 11 is H, 12 is G. I'm sorry, I'm getting ahead of myself. We're getting finished here. 12 is G. Time value of money. Money can be invested today and grow to a larger amount, right? We said $1 today is worth more than $1 tomorrow. And then finally here, right, the last guy, 13, if we look at that, process of elimination, F, right, obligation, sum of cash. So with that, I'm going to end the lecture here, and I'll see you in the next video. Nothing too hard, right? Just take your time. If you're stuck, that's fine, right? It's okay. It's normal. It's natural. Look at the optional problems. Feel free to shoot me an email, and we'll take it one step at a time. But with that, I'm going to end the video here.